Okay, so I think the flow of people has slowed down, so we'll get started. So welcome, this is Jumpstart Your Microservice Development with Java EE. I'm Kate Stanley, and this is Graham Charters. We both work for IBM, and we're hopefully going to give you some information today about why we think Java EE is a good fit for microservices. So this is the contents that we're going to talk to you about today. We'll have a little bit of an introduction to microservices. Just a quick show of hands, who here already thinks they know what a microservice is? Okay, so we'll give a bit of introduction, then hopefully level set where we are, and then we're going to talk about Java EE evolution, some stuff about Docker and microservices, some packaging considerations that you might want to think about while you're creating applications, and then also how you can use the OpenAPI specification, and a conclusion. We're going to show a couple of demos as well. We'll try and keep the talk quite general about Java EE, but because we both work for IBM, we're going to kind of demo the things that we know and we're used to, and hope that the demo gods smile on us today. So let's get started. So what are microservices? They're used to compose a complex application using small, independent, autonomous, replaceable processes that communicate via language-agnostic APIs. So rather than deploying one big application, you deploy it in lots of small pieces, and they come with some advantages and then some sort of complexities and difficulties at the same time. So whenever I'm giving a microservice talk, I always kind of say, go have a look, read. Don't just choose microservices because you think it's going to solve all your problems, because it does have some added complexity. So some of the advantages are that you can scale your applications in individual pieces, you can deploy new versions of the microservices very quickly, but then it comes with some disadvantages of having complexity in how the services interact and how they call each other. The other thing that's worth mentioning around microservices is 12 factors. So 12 factors is a methodology for building software as a service applications. It was created by the developers at Heroku. And although I wouldn't say that you have to follow all of these factors if you want to build a successful microservice, it definitely is a good starting point to get you thinking and having your head in the right space. So I've listed them all there. I'm not going to go into detail today on all of them. But you can go to 12factor.net and read about the different factors. But if you keep these in mind while you're building microservices, then you'll find that your applications are better suited for the cloud and better suited for the kind of environments that you want microservices for. So what should we look for in a microservice environment? So this is not just the 12 factors, but a little bit beyond as well. So obviously some microservice technologies. You might want to look at how are you going to secure your application. One of the other considerations with microservices is because of the communication aspect, you need to consider fault tolerance and what are you going to do if one of your services goes down. Another thing might be looking at how you're going to do load balancing or how you're going to find the services in the first place. So there's some different technologies that you're going to need to look out for when you're trying to decide what you might need from a microservice environment. The next two there come straight from the 12 factors. That's fast startup and clean shutdown. An individual microservice should be something that you can just throw away. And once you throw one away, you should be able to start it up again very quickly. So you'll hear people saying that microservices should be stateless. You don't want to have to do some sort of process where you store some data that was in cache and having to kind of think about that before the application goes down. If that application goes down, you should be able to just start up a new one and carry on. The movement towards microservices has kind of come alongside cloud-native applications and a movement to the cloud. So a small footprint is useful here because you're paying for the amount of space that you're using often, and that's where, again, with microservices, the scaling comes in because you just want to scale up exactly what you need and not have to pay for a lot of space and things that you aren't actually using. Externalizing config is something you want to do for microservices. It, again, comes from the 12 factors. Basically means rather than having your particular application have all the detailed config for that particular environment, you want to be able to inject that config. So that may be through environment variables, for example. And that way you can redeploy your application in many different environments, and you just change the config that gets injected into the application. You don't tightly couple the application with its config. The aim with microservices is to be able to iterate faster and get more out of your application. And with this comes a need to be able to make changes and push them up, and a need for developers to be able to actually run what's in development to be the same as what's in production. You'll find if your developer's doing something completely different from what's in production, then when you try to deploy it to production, you're going to have a problem, and that slows down the amount of time between the developer making the first code change and it getting out to production. And since one of the reasons to move to microservices is to speed up that cycle, then having development and production parity is very important. And then the last one is containerization. I'm going to talk a bit about the advantages of containerization, but it's something you might want to consider if you're moving to microservices.
So it's quite clear, I think, I've heard many people say that there's a perception that Java EE is too slow, too bloated, and I think it's worth looking back through the kind of history of Java EE to understand how we got to that perception. But then also I'll follow on by looking at what some vendors in the industry are doing to kind of move away from this view that Java EE is a large, bloated, slow environment. So if we look back in 1998, when first Java EE came out, it was a small number of specifications and a small number of technologies. And over the years, we've added more and more specifications to get to the point where we are today with Java EE 8. And it was quite clear in the kind of 2009 timeframe that there was a need for something smaller, and so we started creating profiles. So, for example, the web profile, and then EE full platform for all the technologies. But I think what we've seen is that you can create a profile, so web profile, but when I talk to customers, and we have in IBM offerings that align with those profiles, they say, well, that's okay, I like web profile, but I just want this capability. Or actually, I don't want all of web profile, I just want servlet, or servlet and CDI and things like that. So customers are wanting to kind of pick and choose the capabilities that they use. So profiles help a little bit, and I think actually the main way in which profiles help is they give you an understanding of what a vendor provides. So if a vendor says they support web profile, then that's great. You know that if you're going to that vendor, they've got all those capabilities that are part of that specification. But you don't necessarily have to use them all. There are some environments that provide a number of different profiles that go beyond the kind of web profile and full platform environments, so they'll provide cut-down examples. I guess the most common example is Tomcat, which is just the kind of basic web container capabilities. But then what's been happening over the past few years, and we did this in WebSphere with Liberty 5 years ago, is some environments are actually giving you the ability to pick and choose exactly which of the capabilities you want to use. So rather than thinking of Java EE as a platform and you have to take the whole thing and it's potentially bloated and potentially slow and so on, you can start thinking about Java EE as a set of capabilities, a set of APIs, and choose which APIs you want to use to solve your particular business problem. So with Open Liberty and WebSphere Liberty, we have this concept of features. So as you can see, my pointer won't light it up. On the right-hand side, this is just an example of a server configuration that's going to use JAX RS 2.1 and OpenAPI 3.0. So you might be, in this example, doing a REST service and wanting to expose that API out in the form of some document that can then be used by some consumer. And then we let you minify that server down, so it only consists of those capabilities or any capabilities that those capabilities depend on. So you get a nice constrained package that just fits the purpose. In Wildfly Swarm has this fractions concept. That works slightly differently, so it's based off a Maven dependency declaration, so you declare which of the wildfly swarm fraction. You can tell I work for IBM because I can't say wildfly swarm. You pick and choose your wildfly swarm fractions based on dependencies in your Maven POM, and then the build will output an executable or runnable jar that you can then run that includes those capabilities. So that's the kind of EE aspect and the way we've seen not necessarily EE as a set of specifications evolve, but how vendors are providing the EE capabilities that makes it more appropriate and more suitable to do microservices. But then beyond that, there was a kind of feeling that EE was not evolving as fast as we needed to in order to address the requirements for microservices. And so a group of vendors got together and formed microprofile.io, and then sometime later that then moved to Eclipse. So there's now the Eclipse Microprofile project. And the purpose of Eclipse Microprofile is really to evolve and incubate and experiment with API specifications in the microservices space. So the first one, so Microprofile 1.0 was pretty basic. It just referenced 3 of the EE specifications. So it said, you're going to want to use JAX-RS, you're going to want to use CDI for injection, and you're going to want to use JSON-P to work with JSON. And then it started creating its own specifications. The first one was config, which again relates to what Kate was saying about 12-factor. So the config spec lets you externalize configuration outside your application, so you can have this deployable unit you build at the start, and as you move it through your pipeline and test it in the different environments, you don't have to rebuild that thing, you just change the configuration as it moves through the pipeline. Fault tolerance, I won't go through all of them, but I'll pick out some of my favorites. So fault tolerance, when you start thinking about assembling applications in terms of a set of collaborating services or microservices, then you need to start dealing with issues like the fact that there's a network involved and the fact that probably another team is responsible for deploying something that you depend on. That thing might go away, it might upgrade it, it might fall down on it, flat on its face or whatever. So what fault tolerance does is define some APIs, some nice annotations that you define the policies that you want to use in order to deal with the potential unavailability or unreliability of services that you depend on. So it standardizes, I think it's like 5 patterns. So you've got things like bulkhead and, have you got that? Circuit breaker. Circuit breaker, that's another good one, thank you. And also the ability to define a fallback service, for example. So if you retry a service 5 times and you still don't get a decent answer from it, you can go and then call a fallback. All right, so what I'm going to do is just demo, God's permitting, do a quick demo of the kind of right sizing of a server environment. So I'm going to use OpenLiberty. OpenLiberty is an open source app server that this isn't my laptop, so I'm going to be pretty slow. Can you all see that? No? Come to the front. Okay, I'll talk through it. So, what I've done is I've gone to openliberty.io and I've downloaded a zip package of the server. The zip package is 76 megabytes. That includes full Java EE 7 capabilities and Microprofile 1.2 capabilities, which is the latest level of Microprofile. And the install is just an unzip onto disk. So, third time lucky. So we've just got this directory here that's where the server's unzipped. And the first thing, this is the server runtime, but it's not actually a server instance or any server configuration. So the first thing I'm going to do, and I need to find the backslash, is create a server. Okay, so I've created a default server, and I can run that server. So yeah, got the backslash right. And so, I don't think I mentioned this. A lot of the vendors have focused put a lot of effort into having quick startup of servers. So, for example, WebSphere Liberty starts in a few seconds. A lot of the other app servers do so as well. So that's the browser I want, isn't it? Oh, you've even got the URL ready for me. Thank you. we can see it's OpenLiberty running. I've got no apps deployed. That's just a kind of default landing page. And so that's running a few capabilities. So what I'm going to do is just go into the server directory. And this is where the server configuration lives. And got to remember what editors. We've got Visual Studio Code. So if I just edit the server XML. So this is just the default server configuration. Now is that going to pop up in that one? You've got your VM running, haven't you? Yes. Yeah. Okay, so you can see the default server configuration that we have in this particular distribution is it's going to put JSP in, but let's say I just want to do servlets, and we'll put the version of 3.1 version of servlet. And I can save that, and you can see on the server side where it's running, it said, okay, I no longer need JSP 2.3 or expression language 3.0. So now I've got a server that's just running with servlet. Just picked all that up. But then I've done my development, I've built myself an application, and I now want to package that thing up into a distribution. So I'm going to package this server up, and I'm going to make it an executable or a runnable jar. So I need to specify and oops, I'm assuming that's a comma. Okay. So as I said at the start of the demo, at least, the download package is 76 megabytes. I'm now going to package this server up. Oops. And we can see we've now got about 15.5 meg server distribution that just runs servlets. And I can run that thing now, so and I think just about every vendor supports runnable jars nowadays, but I've got it, later on we'll discuss whether runnable jars are the right thing or not. Okay, and if I go back to the browser, I'll just refresh that page, and yeah, you can see the server's running. So that's just an example, and I'll kill that off now so it doesn't cause us any problems. There we go. Right, back to the slides. Oh.
You have to press the. I don't think you have to press. Yeah, do that. Okay.
Well, no. Oh no, I've not got focus on the slides.
You press FN.
Do I need to do? That'll probably do it from the beginning, though, won't it?
Yeah.
Yeah.
You can just click through.
So I probably have to do Shift FN function. Alien keyboard, sorry. Okay, so we've seen the kind of alternative approach to using Java EE capabilities. Now I want to move on onto Docker as a concept. So who here is using Docker? Okay, cool, so you probably know more about it than I do. Who here is doing microservices but not with Docker? Okay, I'd be interested to know what you're using, but maybe not just now. So we see a strong correlation between microservices and Docker and containers. So containers as a concept are built on kind of two capabilities. One is this notion of isolation, so that you can, or namespaces, so that you can avoid clashes of names of certain things in an environment. Linux has this concept of namespaces so that you can avoid conflicts on file system, on processes, on users, and on network, and so on. So that kind of helps you avoid conflicting on those things, and then it has the concept of control groups or C groups, which let you then partition up the resources of the system. So assigning a certain amount of CPU or a certain amount of memory to a particular container. So the control groups helps avoid the concept of nosy neighbor, Don't know if you've heard of that before, but noisy neighbor. So the namespace thing is the nosy neighbor because you can't see your neighbor's stuff. The control groups is noisy neighbor, where essentially if you've got a badly behaved microservice or something running on the same host, because you can constrain the resources it can use, it can't then chew up the whole system. So in the Java EE world, I think for many years, customers have deployed multiple applications to the same application server instance. It's over the years, it's become a much less common pattern because of this noisy neighbor problem. Because what would happen is you deploy multiple applications, one application would maybe have some bad behavior or require more resources, and you'd end up starving the other applications of resources and causing yourself problems. So let's look at some of the qualities of Docker. So what Docker provides. So Docker has this concept of a Docker file. The Docker file describes when you build an image, what you want that image to consist of. So in this particular example, we have already a WebSphere Liberty image that's defined, and we want to add a WAR file to it. And so that will then build another layer on top that includes that WAR that you can then get an image for, and then you can then deploy that as a container. So Docker gives you this kind of consistent way of defining that packaging. It's also a way that's independent of Java, and the concept of microservices is a kind of polyglot concept. You're not going to just necessarily in your organization be deploying Java. You might be deploying many other types of things. So this gives you a nice way of describing all of those things in a consistent way, including things like the externals of the things you're deploying, such as what ports do I need to make available, that kind of thing. I've talked about the layers. One of the nice things about layers is as you reuse them and build things on top, those layers can be cached by the environment. So that means you've got less disk usage because it just caches it, and so there's kind of one definition of it that you then build upon, and less I/O because you're not moving, because they're cached. Each time you build a new image on top, you're not moving those things around again. You've got a consistent API. So Docker defines things like how you can do logging and metrics and volumes and so on. And those things are consistent across the different types of things that you choose to put inside your Docker container. And the final thing is immutability. So you can, and this again relates to 12-factor, you can make the thing immutable by essentially putting everything in it and not referring to things outside, which means that the contents are not going to behave differently as you move it through your pipeline because they're not relying on things in the external environment, things outside the Docker container. All right, I'll hand back to Kate.
Okay, so we're going to see another demo now. And what I'm going to do is create a project with the IBM Cloud Developer Tools CLI, which is a mouthful of a name. But basically, within IBM, we have several different ways for you to generate a starter project. So we have a CLI, you can go in through the IBM Cloud, and there's also a WebSphere Liberty sort of specific page, and they all generate a similar application, but it just gives you a different entry point. So I'm going to generate something, then I'll show building and running with Maven and Docker, and then how you can actually use the Maven and Docker environment to keep deploying your application and without restarting the container. Because if you have to restart your container every time you want to see an update, then that kind of slows down your development time. So it's just a nice way to do development. So I'm going to be running this in a VM because I'm running Windows, and I just find Docker behaves a little bit better if I'm running Linux. So that's why the demo earlier was running a bit slow, because I've got this VM running in the background. So to create a project, I would run bxdev create. So bxdev is the CLI tool that I've installed, and it's asking me here if I want to log into Bluemix. If I logged into Bluemix, which is our IBM Cloud, then I could get it to provision actual services in the cloud for me, so things like Cloudant or any of our Watson services. But for now, I'm going to continue without logging in, and it just won't do any of that provisioning pieces. So it then goes and retrieves what starters, so I can pick my starting point, and here I'm going to choose that I want a microservice. And then I have some options of languages. So you can see at the top we have, I don't know if that's big enough. I make it bigger? Oh. Hopefully you guys can see that. But the 4 options are Java microprofile, Java EE, Node, Python, and then a Java Spring. So I'm going to choose microprofile Java EE because that's what the topic of this talk is, and then I would name my project and create it. I can set that off going. Because of the Wi-Fi, it may or may not generate happily. So I'm actually going to switch across to one that I created earlier while that creates in the background. So I can have a look at the code that I generated earlier. And so here it is. So when you generate an application, you get a whole bunch of content. You get a POM file to build it. You get a Docker file to run in Docker. You also get some Helm charts if you want to run using Helm, and some Bluemix-specific files if you want to create tool chains and pipelines that deploy to Bluemix. So you get a whole set of stuff ready for you to go. So to get started, I might want to build my application with mvn install. So it's set up to run Liberty in this case. That's our Java EE microprofile vendor of choice. And it will build the application, then start up the Liberty server and actually run integration tests against the server. So you can see there it's hitting a health endpoint to make sure that the app's running properly, and then it finishes building. So then I need to build my Docker container. So I've got a Docker file, which is just here, which we can have a look at. So you can see it's based on a WebSphere Liberty image. So WebSphere Liberty has loads of images in Docker that you can check out. And then we're just copying the content from the server over into the container. So if I build that and tag it with J1 demo, so that's building up my container. And as Graham said, it's using caching. So you can see there it's used cached versions of the application server. So it's quite quick for it to build. Cool, so that's done. So now I can run my container. So I could just run it with a Docker run, and then it would start up and I could access my application, and that would all be fine. But in this instance, I'm going to make some changes to my application. So instead, what I'm going to do is run it with a Docker volume. So I did a Docker run. I need to specify a port. So I'm going to specify 9080 as the port. And then I need to specify a volume that I want to mount. I think my volume is at J1 demo. And I know I've got my server is in my target directory. So it's in target. Liberty, WLP, oh, damn it. Okay, accidentally pressed the enter. WLP, user, servers, and it's just called default server. That's the default server name that it gets given. And then I'm going to map it into the config directory. So the config directory is set up for this Docker container so that you can, if you put your config there, then the Docker image for Liberty will just pick up your config. And then I specify the name of my container. So that will start up the Liberty server, and you can see the logs coming out there. And it should pick up the server XML content that I have in the target directory. So if I show you my target directory quickly, in here you can see that when I did the mvn install, it put Liberty here. So I have a whole local version of Liberty that it installed for me. And then inside the user server's default server directory, then I've got my config here, which you'll see is pretty similar to what Graham was showing earlier. And if you choose microservices, then you get the microprofile 1.0 feature, which is the Liberty microprofile feature. So my application is now running, and I should be able to access it. So if I go to this URL, then this should tell me whether my application is running. I get back a health endpoint. At the moment, this is just JSON that's returning, but the aim would be that once the microprofile health specification is available, then we'll switch to using that. I've also got an example endpoint. So if I go to v1 example, then it says some data has been printed out. So then if I go back, I can actually update my application. So the example is running here, and it just says some data. So I can update this to say, hello from Java 1. And then I can save that. Now you can actually set up Liberty within VS Code to automatically update, but for this demo, because I wanted to keep it a little bit vendor agnostic, I'm just going to show running Maven, and some of the other vendors have options where you can actually run Maven tasks that will then do this update for you and will kind of run in the background. So you can see my app from earlier did get created, but if I cd into this one, I'm going to do an MVM package to just reproduce the package that I've just changed. So that's going to, again, compile all of my classes and then copy it across. And we should see the server on the left-hand side view there. It's picked up some updates, so it found that there wasn't a functional update to the server config, but it's noticed that there's been an update to the web application, and it's updated it there. So if I go back and do a refresh, then you can see my new message. So when you're then pushing this through the pipeline, you might want to not use a volume and stick with your Docker file that is your one immutable object that you pass through the pipeline. But for developing locally, it's nice to be able to not have to shut down your Docker containers. No, I didn't rebuild the Docker image, no. So all I've done here is I've mounted a volume into the Docker container. So rather than it using the copy of my config that got copied in by the Docker file, it's actually using the location that I mounted. So when I did the MVM package, it would have then updated in there. And actually, if I'd have used the built-in support that we have in VS Code for Liberty, or we have tools in Eclipse as well, then I could have actually set it up so that I could just change the class, save it, and it would have automatically updated for me. Yeah, so my container is picking up. When I did the MVN install, I got an updated application in this folder down here, in my drop-ins folder, and that's what it's picking up. So I mounted this whole directory, the default server directory here. That's what I mounted, so that's what happened when I did the MVM package. It got copied in there, and then the update happened. Cool, so I think that's all I wanted to demo from that point of view. I'm going to stop the Docker container, because that will slow things down, and then switch back. Cool.
I think that leads on to the next section, doesn't it?
Yes, it does. So this is the demo that I just did. We'll, if we haven't answered your question at the end, then ask it again. But hopefully this should answer that.
People will think you're a plant, and we just got you to ask that just at the right time. Okay, so packaging. So when you're considering the packaging for your microservices, there are a number of characteristics that you might want to kind of ask yourselves. What do I want to achieve from my packaging? Do I want it to be externally configurable because I want to kind of follow the 12-factor practices? Do I want it to be immutable, again, relating to 12-factor, so I can be confident that the thing that I built at the start and ran my unit tests against is the same thing that I'm going to test maybe in my staging environment. Maintainable. We all want maintainability, don't we? And the choices that you make in terms of packaging may affect the maintainability of your microservice. Consistent. So do you want consistency maybe across microservices? So you're deploying many microservices. Consistency can help in terms of people wanting to move teams and work on different microservices and so on. Maximizing reuse and sharing. Again, the approach you take can help maximize reuse and sharing. Do you want separation between what you build as a team or as a squad in terms of the application code and what you're reusing, which might be a vendor's Java EE environment, or it might be some open source frameworks that you're adding into the environment. Having that kind of separation can be important. And then one of the kind of quite often the elephant in the room is the organizational fit. I work with a lot of big customers who have separate dev teams, separate ops teams. Hands up if that's the environment you work in. Yeah. So the ops team stand up a server. That's what they've done for years. They own that. They're responsible for that, and that's great. And the dev team have historically thrown a WAR file over the wall with some configuration or whatever and said, do that for me. And now the dev team's going, I'm doing microservices. I'm going to give you a runnable jar. And they go, what do I do with that? So that's an important consideration, because organizational change is quite often a lot harder than technological change. Okay, so we talked about EE app servers and the ability to customize your runtime environments. We've seen examples of runnable jars, and we've talked about containers. So what's the best choice? What's the best fit? And it can kind of depend. So if you're using Docker, and particularly if you're a polyglot environment where you're deploying multiple things, then you're going to want to use Docker as your packaging mechanism. And the thing is, once you're doing Docker, then you probably want to benefit from all the Docker capabilities. So what we talked about in terms of the layers and the images and the caching and so on. So think about structuring. Oh, I can see it. Think about structuring your environment in terms of the kind of base operating system, putting Java down, putting your server down, and then there might be frameworks and libraries that either you're reusing in open source, or maybe you're developed in-house, and you might want to put those in as a layer, because putting them in there makes them explicit. You know which of your Docker containers are then using those things, and if you've got a security vulnerability or you need to upgrade something, you can see quite easily what your dependencies are and where you need to maybe do a redeploy or rebuild and redeploy of a particular microservice. And then finally add your application thing in. So as you go down that stack, hopefully the things vary less often. The things at the top are the things that are going to change the most, which is your application code. And if you're doing runnable jars, then you get, I think, less flexibility, and also it doesn't particularly work very well for a polyglot environment. However, even if you're using Docker, as I mentioned about the organizational aspect of it, you might not be the person that creates a Docker image. That might be your ops team, in which case WAR, again, is probably the best thing for you as a development team to create as a package, and then you give it to the ops team, and then they go and do the Docker things with that, rather than giving them an executable jar, which they've then got to go and look inside and try and find your WAR file and pull it out and go and put it inside a Docker container. Okay.
So the last thing we wanted to talk about here today is the OpenAPI specification. So for those of you that aren't aware, it's a simple standard API description format. Version 2 was released back in October 2014, and back then it was from Swagger. And then now version 3 is the OpenAPI specification. So the Swagger kind of specification Swagger was donated as part of the OpenAPI specification. And there are some different implementations, so I've mentioned Swagger there, and often people use Swagger and OpenAPI as interchangeable words, and you can find a lot of vendors actually support this as part of their application service. So for example, with Liberty, we have a feature that provides it, and again with Wildfly Swarm, they have a fraction that provides it. Why is this useful for microservices? Well, for microservices, communication between the services is really a key aspect that you need to get right. Because you're suddenly in a distributed system, you need to have good communication between those different parts. And along with microservices often comes an organizational change where you have different teams that own the different microservices, from sort of writing the code all the way up to deploying and support. And that means that you need a well-documented API between the different microservices. So the OpenAPI specification comes in very well here, and it can be used in testing specifically to make sure that both the producer and consumer of a particular API is keeping to the specification that you have chosen. And there are a set of different tools that you can use. One such tool is something called Pact, where you can define tests that can be run by the people producing the API to make sure that they haven't regressed anything or changed anything that would break their consumers. Another thing to think about is microservices driven by a desire for short life cycles. So rather than having one big application that started being written a long time ago and then you just keep adding pieces on the edge, you're likely to be writing new applications much more frequently. And with that, it's useful to be able to have some auto-generated code. So I already demonstrated today how we generate an application, but actually being able to generate based off a API specification is very useful, and that's where OpenAPI documentation can be used. It's also polyglot and a multi-vendor environment. So you can use OpenAPI even if your microservice is made up of services that are all in different languages. So for myself, when I've been working with my colleagues who have microservices that need to interact with mine, even if theirs are written in, say, JavaScript or Python or whatever, we can all have this one view of how they should interact. So I mentioned code generation. There's a lot of open source tools available. If you go look on Maven, for example, there's a whole set that you can use. And some of the vendors actually supply like built-in support for you to generate code based on specifications or generate the actual document to show the specification of your API based on the code. So you can go both ways. So in the IBM Cloud, we have an option for you to generate an application given the document, and we also provide this from the Liberty App Accelerator, which I mentioned earlier, so you can see the Swagger button there in the corner, and the Wildfly Swarm project generator, which is sort of their equivalent to the App Accelerator, also provides this option. So here's a quick sort of diagram in case you're not aware of what it might look like if you were going to use this technology. So you can have your actual endpoint specified in similar way that you would with just JAX-RS, and then you can add extra sort of user information as well with Swagger. And the nice thing is it produces this UI. So I've used this a lot when we're doing development, because it's a nice way to visualize the API and get a real understanding for what the team want out of the API and how you might interact with it. And so, for example, with Liberty, if you use their API discovery feature, then you'll get this UI as part of that. So, in conclusion, we think you should consider the individual capabilities of Java EE. It isn't something that you have to take as one big lump. You can choose the different pieces that you want and make it the right fit for you. You should choose your runtime to fit the particular capabilities that you require, and different vendors provide different options for how you can do this. With Docker as the packaging model, jar files maybe isn't something that is useful, and actually you can just stick with a raw file, but again, it depends exactly what you're doing. But having Docker as something that's in your environment will definitely be useful for microservices. And then, of course, the microprofile community adds a programming model essentials and removes boilerplate that you would otherwise have had to write. So it provides annotations and things to get your microservice written more quickly and sort of the code more clean. Finally, we've got the Swagger or OpenAPI specification, which you can make use of as part of Java EE. The different vendors support it, and then it can be used even if you've got a polyglot environment. So we've got a few resources here. If you want to go read more about microservices, there's a red book which I actually co-wrote with some colleagues of mine, and that kind of gives a general overview for Java, but it's got some Java EE specifics in it as well. WasDev.net is the WebSphere Liberty developer site, so all the developers, myself and Graham included, that work on Liberty have written articles up there and documents about microservices. And then you can also go to Microservice Builder, which is the sort of Liberty and IBM Cloud private version of the BXDev tools that I showed you. And then, of course, we've got links to Open Liberty, which we've recently announced, and MicroProfile.io. And if you want some reading, then we've got some resources for you to check out as well. So I think that's about all we have time for. Thank you very much for coming, and we welcome any questions.